Welcome to This Explainer. Today, we're diving into something that literally touches almost every aspect of our modern digital lives, but mostly flies completely under the radar. You know, when we talk about the cloud, or AI, we kind of picture this ethereal, weightless data just floating out there in the digital ether, right? Well, actually, scratch that. The reality is radically different. Every single prompt you type, every image you generate requires massive, energy-hungry physical infrastructure. Today, we're unpacking the AI environmental paradox, the staggering physical costs of our new digital brains, why these costs exist, and why, despite the heavy environmental toll, mastering this technology is absolutely crucial for our future.
Okay, let's dive right into this. Here is our roadmap for today. 1. The AI energy explosion. 2. Hidden water and hardware costs. 3. The efficiency paradox. 4. AI as a climate solution. And finally, 5. A necessary balancing act.
Starting off with Section 1, the AI energy explosion. Let's look at the most immediate metric, electricity. To really grasp the impact of generative AI, we've got to compare it to a baseline we're all super familiar with, which is a traditional internet search.
For years, traditional search engines have been hyper-optimized. When you run a standard Google search, you're essentially just querying a pre-compiled index. That quick action uses a tiny amount of energy, about 0.0003 kilowatt hours. But generative AI is a whole different beast. It doesn't just retrieve information. It actively calculates and generates brand new text, word by word, firing up vast neural networks. Because of all that heavy computational lifting, a single ChatGPT query uses about 0.0029 kilowatt hours. Meaning asking an AI a question requires roughly 10 times more energy than your standard web search.
So what does this all mean for carbon emissions? Brace yourself, because it's not just a 10x increase. Because of the sheer scale of the infrastructure involved, a standard search emits about 0.2 grams of CO2. But a single AI query, that can emit up to 68 grams. That is a 340 times higher CO2 emission rate per query. I mean, one prompt feels totally harmless to us, but this difference is just staggering when you apply to a massive global user base.
So the crucial point here is how this scales. ChatGPT alone processes roughly 200 million queries every single day. When you actually do the math on that 10x energy penalty, it translates to 621.4 megawatt hours of energy used daily just for operations. To put that into perspective, running this one single AI tool for a year consumes the equivalent electricity of over 21,600 average American homes. And remember, that's just a daily inference, just answering questions. That doesn't even account for the massive energy used to initially train these models, which eats up thousands of megawatt hours over weeks or months. But electricity and carbon are really only part of the story. Moving to Section 2, hidden water and hardware costs. Let's shift our focus from the power grid to the resources that are entirely invisible to us as end users, yet equally critical: the fresh water used to cool the servers and the physical hardware itself. Data centers get incredibly hot, especially when they're running intense AI workloads. They require immense amounts of water for cooling. Researchers actually estimate the training just the GPT-3 model, and keep in mind that's an older model, not even the newer, larger ones, directly evaporated 700,000 liters of clean, fresh water across data centers in the US alone. And this water footprint is highly dependent on where the data center is located and the local climate. They're often drawing from watersheds that are already experiencing moderate to high water stress. To make this a bit more visceral, researchers calculated the operational water footprint of AI inference. Depending on the season and the specific location of the data center, an AI essentially drinks a standard 500 milliliter bottle of fresh water for every 10 to 50 medium-length queries you type in. So every time you have a back-and-forth brainstorming session with an AI, you're effectively emptying a bottle of water into the atmosphere. It's this very real, localized environmental stress caused by a seemingly invisible digital action.
Now, what's really interesting about this is looking at the true lifespan of AI. This is a cradle-to-grave emissions boundary from Google's lifecycle assessment of their tensor processing units, or TPUs. Before an AI even answers its very first question, it incurs a massive environmental debt. This is called Scope 3, or embodied emissions. We're talking about the mining of raw critical minerals, the highly complex manufacturing of specialized silicon chips, shipping that hardware to data centers, and the eventual disposal and e-waste when those servers are retired just a few short years later. When you break down the entire lifecycle carbon footprint of an AI model, the embodied carbon from simply creating and installing the hardware can account for up to 35% of the total emissions. Training the model takes up about 20%, and the daily usage, inference, and storage makes up the remaining 45%. This is a huge realization. It means that even if a tech company powers its data center with 100% renewable solar or wind energy, they're only fixing the operational side. More than a third of the carbon damage has already been done just by building the machines in the first place.
Which naturally brings us to a complex hurdle. You might be wondering, well, technology always gets more efficient, right? Won't the next generation of chips just fix this? That assumption leads us directly into Section 3, the efficiency paradox.
Have you ever heard of the Jevons paradox? It's this 160-year-old economic principle. It was originally observed with coal and steam engines. Basically, making engines more efficient didn't reduce coal use. Instead, it made steam power so cheap and profitable that people built way more engines, completely skyrocketing total coal consumption. Well, the exact same thing is happening with AI. Google, for instance, announced incredible engineering feats, like a 33-fold reduction in energy per query for their Gemini model. But because this makes AI cheaper and faster, we're embedding it into literally everything. The per-query cost drops, sure, but the total volume of queries absolutely explodes.
Digital Sustainability Officer Eli Toftoy Anderson really hits the nail on the head here. He points out that efficiency announcements carry a hidden danger: complacency. People hear 33-fold reduction and think, great, the problem's solved. But despite these massive per-query efficiency gains, the overall carbon footprints of major tech companies have surged. Some are up by nearly 50% since 2019, and that's driven largely by the sheer scale of expanding AI infrastructure. Technical optimization alone just can't outpace exponential growth in usage.
On to Section 4, AI as a climate solution. So, given this massive energy explosion, the evaporated water, the e-waste, why do we even continue? Why not just pull the plug on the whole shebang? Because, paradoxically, mastering this heavy-polluting technology is quickly becoming our most powerful weapon for human progress and protecting the planet.
And this brilliantly illustrates why AI is a necessary tool. Just look at these breakthroughs. Google DeepMind is using AI to develop enzymes that can actually break down the 400 million tons of plastic waste we produce annually, aiming for a fully circular, 100% recyclable plastic economy. Then you have AI models like Pangu Weather mapping extreme climate events and forecasting weather with unprecedented speed and accuracy, literally saving lives. And initiatives like Project Greenlight, they use machine learning to optimize city traffic signals, vastly reducing stop-and-go emissions at intersections. AI is fundamentally accelerating the scientific discoveries we desperately need to survive the climate crisis.
So this leaves us standing at a crossroads. Section 5, a necessary balancing act. We have a technology with a massive, undeniable physical cost, but one that is also uniquely capable of solving our most existential threats. Managing this tension requires a serious balancing act.
Thankfully, regulators are beginning to step in to create guardrails for this explosive growth. The European Union adopted the AI Act, which is the world's first comprehensive framework, and they are moving fast. By February 2025, systems posing unacceptable risks were banned outright. By mid-2025, massive general-purpose models have to comply with strict transparency rules, detailing their data and energy usage. And by 2027, high-risk systems embedded in critical infrastructure will face rigorous compliance standards. It's a very clear signal that society is demanding accountability alongside all this innovation.
Let's look at the actionable path forward. True digital sustainability requires us to go way beyond just writing more efficient code. Organizations need to establish diverse committees to ask a fundamental question. Do we actually need to use AI for this specific task, or is traditional computing enough? Developers must use tracking tools, like CodeCarbon, to transparently measure their footprint. And we have to demand supply chain transparency, factoring in the human labor, the raw materials, and the e-waste associated with those incredibly powerful servers.
Which leaves us with this final provocative thought. Can we innovate fast enough for AI to save the planet before its own footprint destroys it? The reality we have to accept is that AI's environmental impact is immense, yes, but in our current era, the technology is fundamentally necessary. We can't uninvent it, and we desperately need its problem-solving power for these global challenges. The goal isn't to stop AI, but to practice digital sobriety, deploying it thoughtfully, demanding sustainable data centers, and ensuring the environmental benefits of AI drastically outweigh its physical costs. Thank you for joining me on this explainer. Keep asking questions, and I'll see you next time.